Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab, a channel especially created for you and I to tackle the mystery behind mathematics and face headlong the age-long phobia associated with this all-important subject, one topic at a time. Today, which promises to be very exciting and interesting, we are delving further into the topic quadratic equation. From our last video, where I introduced the topic, I did mention that there are 4 methods available to solve problems in quadratic equation, and these are factorization method, completing the square method, general formula method, and of course the graphical method. And in the last lesson, we focused more on the first method, which is factorization method. And I did emphasize that not all quadratic equation problems can be solved by factorization method. And how then do you know which can and which cannot? And then I explained the concept of testing for factorizability by using the expression b squared minus 4ac and the value we get comparing with a perfect square. If b squared minus 4ac is equivalent to a perfect square, then of a necessity, that question can be solved by factorization method. However, if b squared minus 4ac is not a perfect square, then that method cannot work. Hence, we need to look for other methods. And today, we are looking at one of the other methods when factorization method fails, and that is completing the square. Completing the square is a unique method in the sense that it has a set of algorithms or steps that must be strictly followed. And if that is done, then there's no problem. And interestingly, this method is what led to the general formula method indeed. So I enjoin you to sit back and let's have fun. So we are going to solve by completing the square method. The question say y squared minus 8y plus 9 equals 0. Ordinarily, if you are in an examination, you have to solve this question without being told what particular method to use. The easy method that you might tend to use is factorization method. However, a quick check to know if this question can be factorized. And that is our usual test for factorizability. So b squared minus 4ac. A is 1, b is minus 8, and c is 9. So let's slot in these values. We have minus 8 all squared minus 4. A is 1 and c is plus 9, of course. So minus 8 squared is plus 64 minus 4 times 1 times 9 is 36. So when you subtract this, you're going to have 28. And 28 clearly is not a perfect square. Hence, we can never use factorization method for this problem. So this is how you know. If that's the case, now let's stick to the original method we are asked to use. So please, I enjoin you to please pay attention. It can be tricky at first, but it's very simple. For completing the square method, the very first thing is you must ensure that the coefficient of the squared variable is 1. In the case it is not, you must ensure it is 1. However, this question came naturally with 1 as coefficient. So that's the first headache tackled. So the next step, remember I said, is like an algorithm. We just follow the steps. The next step is to move the constant to the other side, and that's going to be minus 9. Then this is where the name came from, completing the square. We are adding something to both sides. We are having this y squared minus 8y equals to minus 9. We are going to add same thing to both sides. What's that same thing? The coefficient of the y value here is minus 8. Half of that, which is minus 8 over 2, then squared. Similarly, do the same here, minus 8 over 2, then squared. So that means basically y squared minus 8y plus, this will become, note, necessarily the sign of the coefficient must also be included in the bracket. That's very, very important. If it is plus, I have to include a plus. If it's a minus, as it is here, I have to include a minus. Very important. Then equals minus 9 plus also minus 4 whole squared. Then the next step is the two values that have the square, which are y and minus 4, must be in the same bracket. I have y and minus 4, and the square is outside. I have completed the square here now. So if actually I open this bracket by expanding, I am going to get exactly this y squared minus 8y plus minus 4 squared. Then equals to minus 9 plus minus 4 squared here is 16. Then I have y minus 4 all squared equals minus 9 plus 16 is 7. Now, so we have y minus 4 will equal, when you take square root of both sides, we have plus or minus root 7. Anytime you take a square root of a number, you must necessarily have plus or minus. And lastly, I'm going to have y is equals minus 4 comes down, becomes plus 4 plus or minus root 7. And that's the answer. That is completing the square method. If the question requires, you can use your calculator or other devices to compute root 7. You add that to 7 and also subtract from 7. And that is the solution to the problem by completing the square method, which I believe you found a bit interesting. But with the second example, you're going to get it clearer, I believe. So let's move on. For example 2, we are still expected to use completing the square to solve 2y squared minus 5y minus 12 equals 0. Okay, a bit of a challenge here. What's the challenge here? The snag is that you have a value other than 1 as the coefficient. And as I mentioned earlier on, that the very first obligation you have is to ensure that the squared value has 1 as coefficient. Now, question 1 came naturally without coefficient other than 1. However, for question 2, there's a value here. So what you're meant to do here is to eradicate that value by dividing through with the coefficient. I'm going to say 2y squared over 2 minus 5y over 2 minus 12 over 2 equals 0 over 2. That's step 1. And that reduces to y squared minus 5 over 2y minus 6 equals 0. Okay, we are now at the default mode, which is to have 1 as the coefficient. We then proceed to solve as before. That means we're going to have y squared minus 5 over 2y. The next step is to move the constant, which becomes plus 6. Plus 6. And then the next step is to complete the square. And completing the square means add to both sides the square of the half of the coefficient. So half of this coefficient is minus 5 over 4. And you square that. Same here, minus 5 over 4. And you square that. So the next step is to include the two terms that have square in a singular bracket. We have y minus, again, take note of the sign, all squared, equals 6 plus, this becomes 25 over 16. Hence, we have y minus 5 over 4 all squared. When we simplify this as our LCM over 16, so we have, of course, this means 6 over 1. So 1 in 16 times 6, that is 96. Plus 16 and 16 is 1 times 25, we still have 25. Hence, we have y minus 5 over 4 all squared equals 96 plus 25 is 121 over 16. 121 over 16. So the next step is to move to square both sides, rather, take square root of both sides, rather. That means I'm going to have, of course, plus or minus root 121 over 16. Anytime you take a square root, you must accompany it with plus or minus. Then we have y minus 5 over 4 being plus or minus root 121 is 11, root 16 is 4. So at this stage, I have y being equals to plus 5 over 4 plus 11 over 4. I'm separating this plus or minus now. Or the same 5 over 4 minus 11 over 4, because these are 2-in-1 operations. So 5 over 4 plus 11 over 4 on one hand, the same 5 over 4 minus 11 over 4. So we have what here? When you simplify this, I'm going to have 16 over 4 or minus 6 over 4. Then I'm going to have 4 or minus 3 over 2. And that exactly are the roots or solution of this quadratic equation using completing the square method. And with that, we've come to the end of this method of solving a quadratic equation. As I said earlier on, the method is a bit methodical, really. We've got to learn how each step plays out without making mistake. And as I said earlier, when you see a question, the very first thing you need to do is to ensure it's not factorizable. And then you also make sure that necessarily the squared value has 1 as its coefficient. If it doesn't, and if you have done that, then follow the procedures, complete the square, and be very careful and meticulous in serving each step. I believe you found today's class quite interesting and revealing, and most importantly, exciting and fun, as I did. If you did, please don't hesitate to subscribe, share, view, and most importantly, turn on your bell so that you will necessarily be the first to know when our next video drops. Thank you and stay blessed.